Hi everyone, my name is Vinay. With me is my teammate Antan Tyagi. We represent the Group 8. Today we want to represent a project called as Income Dataset, Adult Income Dataset. In this, we wanted to evaluate what are those factors being shared among the top earners in the US and some of the demographics, some of the socioeconomic factors which we have analyzed in this project. We want to discuss it with you. Also, we have created a predictive model around the same data set and see if we can predict if one individual can be a high income or a low income individual. So the project, the model is called the income prediction model, and the contributors are Vinay Mittal, who will be representing the EDA and data analysis part. Second is Antan Tyagi, who will be representing the modeling and tuning part. I'll just give an overview of the total dataset. This dataset is introduced by Baker and Kohavi in 1996, containing demographic information of individuals from the US Census. It is primarily used to predict whether an individual's income exceeds $50,000 per year based on the features like age, education, occupation, and more. Now, what are those factors which we have seen in this dataset? There are age, work class, education, marital status, occupation, relationship, race, sex, native country. These all factors fall under the demographic information and mostly are categorical data. Next, we have socioeconomic factors like final weight, education norm, capital gain, capital loss, hours per week. These are some of the factors which we are mostly represented by numeric value. Then we have the target variable, which is the salary, which we are most likely gonna predict. Now, in this project, we have followed the CRISP TM framework, which encompasses 6 key stages, which are being highlighted on your screen. Now, if I jump to the interpretation of the data and the visualization, what are the key findings we have seen in the EDA process and what graphs has plotted? First is the demographic breakdown. We have noticed that the age is ranging from the 17 to 90 years. The working class is including private, government, and self-employed, and the education is right from the high school to the advanced degrees. What we have seen is that majority of the individuals have a high school education or less, and the large portion of the population works in the private sector. Now, these are some of the key observations we have noticed that the individuals with a higher education levels like bachelor's or master's are more likely to earn above $50,000 per year, as well as professionals and managerial roles are the prime occupation leading to the high income group. Also, older individuals, typically more than 35, earn more. Working more hours per week also increases the likelihood of earning a higher income. So yeah, these are some of the factors which we have noticed influencing the income. Next, let's talk about the distribution of income by education, by gender, and by race. So we have seen, we can notice that the box plot representing on the screen is for the education norm, where higher number of years put into the education leading to higher income group. The male are dominating in the higher education years. The APEC and the whites are more dominating in the higher education norm. Now we have already seen that there's a clear trend with higher education levels tend to earn more. So education is a strong predictor of income. We also seen that men are more likely to earn $50,000 compared to women, and we also seen the white and the APEC are more likely to have a high income earners than the other racial groups. We also tried to create correlation analysis. So if in the screen you can notice some of the factors are quietly intercorrelated, like the one in the bottom most left side, hours per week versus age. So what we have observed in this is the strong positive correlation between age and hours per week. That is, the more hours per week tend to work, individuals earn more. So we have noticed a weak positive correlation. Also, we have created a chi-square test to find the association between two categorical variables. Here on the screen, we can see a chi-square test between test, sex, and income. On the left side is the observed frequency, whereas on the right side is the expected frequency. Now, interpreting those, we can see that the left side indicating that there are more male in the dataset and higher proportion of males earning more than $50,000 compared to females. Also on the right shows that the expected frequency and the p-value is significantly statistically significant because it is lying less than 5%. So in conclusion, the high chi-square statistic, that is 2250, and a very small p-value indicate that there is a significant association between sex and income. This concludes the EDA data analysis and data interpretation part. I request my friend Antan Tyagi to take over the modeling and hyperparameter tuning. Thanks.
Hi. Now we move on to the, since we have completed data analysis and all of the statistical inference, we now move on to modeling and hyperparameter tuning. The modeling and hyperparameter tuning can be divided into 4 stages. The first one is data preprocessing. The aim of the data preprocessing stage is to prepare the data so that it can be consumed by the model in their respective states which they require. It involves like making categorical variables to numeric ones and all of those transformation. The following steps for this exercise, these are the steps that I use for data preprocessing. First is the education variable was dropped, since there were 2 variables reflecting education. One is an education and education num. And education num was already a categorical variable of the version education. So we dropped in the education variable. And we all name every dash to a hyphen, basically to prevent any system errors, since dash can be construed as a minus somewhere. We replace all the question mark with np.nan in work, class, occupation, and native country, because technically those are indicators of nan. And we plotted the distribution of work, class, and native and replaced them with the mode distribution of the variable. And we dropped all the null in the occupation category because we did not have any clear distribution. You can see from the distribution in like country of people, the private is the one which is highly reflecting, and in the native country we get United States as the one, whereas in the occupation we do not get any distinct indicators, so we dropped it from there. So next we move on to, after the pre-processing, we moved on to data modeling, where we prepared data for machine learning model consumption. And we took the following steps. We first created label encoding, which converts all categorical to numerical variables, then scaling so that all the other algorithms can work on the same stand. Then we created a train test split we basically created a train test split of the data, and then we did a baseline classification to identify the baseline model performance and then tune the further. For baseline classification, we used logistic regression, decision tree, naive boost, and random forest XGBoost for that purpose. We plotted the AUC ROC score for our algorithms. We saw from the performance that XGBoost classifier has the best baseline performance, and then we move ahead to tune our XGBoost model. For hyperparameter tuning, we use Bayesian optimization because it's a faster method to search for hyperparameters in a large set of parameter scale, and is efficient and scalable, especially for algorithms who have a lot of hyperparameters like an XGBoost. So we used HyperOpt, which is a open source implementation of the Bayesian optimization library. And for the test parameters, we used AUC as the optimization and tree Parson estimator dust suggestion as the algorithm, which ran for like 500 evaluation with early stopping in place. These are the best parameters we obtained from it. Best parameters for the XGBoost, hyperparameters for the XGBoost model. With AUC score we found a marginal AUC score jump from 923 to 9258. And we also had a good jump in precision with somewhat drop in default. But however, for this purpose, we went ahead with the AUC score. So we draw the final conclusion from this exercise. In the project, we built a generalized method to explore the data analysis and build a model to fit the given data. The framework that we adopted based on CRISP-DIEM is a generalizable framework which can extend to various data science problems. In this, we explored the income dataset to better understand the statistical technique which are taught in this framework and how can we apply them to real-world problems. We implemented descriptive and inferential statistics to identify relevant variables for the model and relevant variable for business understanding, and which can be further used for various purposes. We tuned the then we explored different algorithms to figure out which algorithms work best. Since there is a no free lunch theorem, we have to try out multiple algorithms to get the best algorithm for our dataset. We then tune the hyperparameters to get the best fit for the model and performance. And we also explore different hyperparameter tuning techniques and get a final outcome of it. Based on the exercise, we built a strong foundation and an approach which can be used to tackle any data science problem, and basically breaking all the data science problem into relevant parts and then build a logical scoring framework to solve them. All right, that's all. Thank you.